back with a new lesson. Our lesson today is Chapter 10, Lesson 2, Area of Triangles and Trapezoids. Let's start. Our second lesson, we are completing area. Let's make refresh again. What is the difference between perimeter and area? We said the perimeter is the length surrounding or around the shape, and area is the space inside the shape. Do you remember this example? How we can find perimeter here? We will count all the length around the shape. Do you remember? Excellent. Okay, and area we will count all the squares inside. Let's count. Yalla, let's count. 5 plus 5 plus 5. Okay, so this area and this perimeter. Today we will check the area of triangle and trapezoid. Area of triangle is half base multiply height. Half base multiply height. What is the height we said before? We said h is the vertical height. It's from the vertex up to the base down. If I have here base, so I have, this is the height. Here, if it's a right triangle, so it's easy. Right triangle, so from here to down. Here, it's not a right triangle, so I need to find the height from the vertex up to the base down. So what is the area if I have B and H? Just half B multiply H. Half B multiply H. What is the area of triangle? Half B multiply H. Half base multiply height. Half base multiply height. Again, what is the area of triangle? Half base multiply height. What is the area of trapezoid? Okay, let's see the area of trapezoid. Trapezoid, we have here two bases, one up and one down, A and B. And we need the height, the vertical height. We said, what is the vertical height? It's the perpendicular line between the two bases. It's the perpendicular line between the two bases. Okay, we will add the two bases, the two parallel sides, okay, or the two bases, and then we will divide it by 2 and multiply by the height. Let's see the formula here. A plus B divided 2, then multiply H. A plus B divided 2, then multiply H. Let's see example here. I have the two parallel sides for the two bases. Base 1 and base 2 is 2 and 5 centimeters. And the distance between them, or the height, the perpendicular lines between the two bases, is 10 centimeters. So how we will find here the area? The area will be 2 plus 5, and then we will divide it by 2, and the result will be multiplying by 10. 2 plus 5 is 7 divided 2, that's mean 3 and a half. Multiply 10, 35 centimeters square. That's clear for trapezoid. I want you please to go and watch the video, and then I will see you next time on our exercises. Thank you.
Okay, now that you know how to find the area of any square or rectangle using our formula, we're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again.
What?
The dimensions of this rectangle are 3 meters by 4 meters. So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, what if we were to cut this rectangle exactly in half along a diagonal line from opposite corners? It forms two triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared, and the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference. Instead of L for length and W for width, we're going to use two different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the three sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground, like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground. The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle. And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these two measurements, base and height, we can just plug them into our formula to calculate the area. At first, you might not see how the same formula could work for all three types of triangles, but watch this. Here's an acute triangle, and this box is 1/2 its base times its height. If we cut our triangle up, you can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now you can see how the formula, area equals 1/2 base times height, works for any kind of triangle. Okay, we already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last two triangles. Our diagram shows that the base of this acute triangle is 5 meters and its height is 8 meters. So we plug those values into our formula for area and we get area equals 1/2 of 5 times 8. 5 times 8 is 40 and 1/2 of 40 is 20. So the area of this triangle is 20 meters squared. Don't forget that the units of measurement for area will always be square units. Okay, that was pretty simple. Let's try our last example. The diagram of this obtuse triangle tells us that the base is 4 inches and the height is 7 inches. So let's plug those values into our formula. We end up with the equation area equals 1/2 of 4 times 7. 4 times 7 would be 28, and then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches. Okay, now you know all the basics of area. You know that area is a two-dimensional quantity that we measure in square units. You've learned the formula for calculating the area of any square or rectangle. Area equals length times width. And you've learned the formula for calculating the area of any triangle. Area equals 1/2 of base times height. But don't forget to practice what you've learned by working some problems on your own. That's how you really get good at math. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.